Welcome. So while doing the slides, I was looking at this title and I thought it was a bit too long. So I thought of actually changing it a bit. So today I'm going to talk about debugging while having performance in mind and while doing it using real-time statistics. So I'm Hugo. I'm a Portuguese developer based in Oslo. I work for a company called Varnish Software, where I have the title of product manager. For those who don't know, Varnish Software is the company behind the open source reverse HTTP proxy, Varnish Cache. Can you raise your hands if you've heard of Varnish before? Okay, good. Great. So when we talk about web performance, most of us think about speed. It's the first thing that the majority of us it comes to mind. And then we have several things in this space. We have A/B testing that can help you, monitoring scalability, we have architecture, we have all these buzzwords. But in the end of the day, it all is cost. Cost for our users, cost for us, that time, our servers, etc. So today I'm going to approach the web performance more into like a debugging kind of approach. So this is probably familiar to you, to most of you. This is the DevTools of Chrome, and this is basically the network tab where you can see the calls for the backend. So if you're a front-end developer, you've probably used this a lot. So you see the different calls, the time it takes for each of the requests to go to the backend. And here you have Flamechart, which is basically the call stack in JavaScript. So this is typically where a developer has a problem in their web application he goes to. And of course, if you're more of a DevOps sysadmin guy, you go into logging your server and you check the logs. Here, this is just a Apache log, simple. So I had a Siege script running, and then this is just an example of that. But I want to diverge a bit from the debugging to tell a small story and then come back. And of course, with that, it comes a solution. So this is a Rotary printing machine. And before it was invented, typically people would assemble small letters or words or sentences against a sheet of paper with ink and then print. And it was a very long and tedious process. And when this printer was invented, a cylinder with a momentum allowed it to print copies very, very fast and save a lot of time. So Varnish Cache is a bit a Rotary printer for the web. It serves copies of your content really fast without going to the backend. So typically, you have something like this, your clients doing requests and then your servers doing responses. Varnish is pretty good at two things. It's pretty good at allowing you to solve technical problems, like you have resource starvation, etc. And also, it's pretty good at speed. Varnish sits between your clients, your servers, and then here you can see that actually then strip down the backend request, backend response, etc. And the logic goes inside that small box there. So now I'm going to explain a bit how the process works. So when your request comes, Varnish fetches the content that's requested from the backend. It then makes a copy in memory and serves that same content to your client's request, to your client. The next time, if based on the same premise, Varnish will serve that content from memory into the client, avoiding calls to the backend. Of course, it needs to be with the same premise, but this is a very simple approach. You can do much more than this. So now I'm going to talk about Varnish configuration language, which allows you to configure this logic in your Varnish server. This is a state machine of the Varnish language. So don't I'm not going to go through all the detail. It's quite complex, but it's just to have an overview how many things are going on inside the Varnish server. And all these calls there, all these routines, are built-in subroutines. And the good thing in this is that in each of these subroutines, there are objects that we can manipulate and change. So let's say HTTP headers, you can pretty much do anything you want inside these routines. And there are routines dedicated to the front end and to the back end. Or, I mean, to the client side and to the back end side, sorry. So now, going back to the logging, the Varnish log works in a bit different than other servers or web servers. So the Varnish log is in memory. It's pretty much 80 megabytes, and it has the structure of a ring buffer, so it uses a shared memory log. And by this, we avoid writing to file, and it's quite fast. And I mean, in files, you have problems where it's pretty hard to write to the file in terms of the logic and then sequence and then I/O, etc. So and most importantly, it's enabled by default. So when you have a problem in your website, typically you go back and, oh, now I need to enable some logging or extra logging to figure out what's going on. In Varnish, that logging is always happening, so you don't need to go back and figuring out, try to replicate the problem. It's already there. So this is an example of Varnish log. On the left, you have the Varnish log more to the client side, and in the right, more into the backend. But in fact, this is a full stream of data. Up there, in request, you have an ID. So that ID allows us to group the full requests from the client request, backend, and coming back in a full log where you can see pretty much what's happening. And this is happening it's very fast and it's happening in real time. Of course, if you have a lot of data, because we have this structure of a ring buffer, after a while, it gets erased. But still, 80 megabytes, it's a lot of data. And all of this is queryable. So you can query pretty much everything that's there, these objects, you can query and extract them. And here is something that we have also, which reads also from the shared memory log, which is the Varnish and CSA. But here is more like a patchy kind of approach. Still configurable, you can still configure what's there, but it's more of a traditional logging. So why Varnish? Why use Varnish? It's really fast. It's used by, I checked yesterday, 2.5 million websites in the world, typically big websites. You can change the configuration on the fly, so you don't need to restart it. You just need to change your VCL and apply the configuration. And the way the logging works doesn't slow down the core functionality. So that's from our point of view, is very interesting. And because everything that's HTTP goes through Varnish, you can do a lot with it. So now I want to talk about how we at Varnish Software use the power of Varnish log to build something else. We call it Varnish Custom Statistics, which is an in-memory database that processes Varnish log and creates time series. So this is the architecture of VCS, Varnish Custom Statistics. So you have your Varnish servers and then the shared memory, and then you have this thing which we call the probe. The probe then reads from the shared memory log and sends the data to the VCS through 0MQ. Then VCS does all the aggregation in time series and exposes the JSON API. Basically, this VCS probe reads from the shared memory log through these VCL-based keys that we write in the VCL, that configuration language, and then it sends it to the VCS server. So I'm going to give some examples in how to use it. So for instance, this is a typical routine, like a VCL receive, is the first routine that gets triggered when the request comes. And here, just checking the user agent HTTP header and doing a regular expression matching with Mozilla, and then we set a key that we called user agents, and then for Mozilla, and then we do some other things, and we could even do more crazy things with regular expressions if you have a crazy user agent that you want to track, etc. This is just a simple example. And the output would be something like this. This is actually a time series, like a bucket of data, and you can actually choose how much data that bucket has, like 10 seconds, 30 seconds, etc. And by default, you get all these counters. And the interesting bit here, for instance, is the time to first byte, miss, and hit is very important because you can figure out how fast we are delivering the first byte to your client. Also, if you notice here, we have the HTTP codes, like let's say in the 400 range. You have, in this example, there were 83 requests that got a 400. So this is interesting in terms of debugging. So you could, in real time, check that there's something wrong, and you can take action. Here, for example, it's the top 400 range errors. That's for the top 10, and then for the last 5 buckets. In this case, my example was running buckets of 30 seconds. So this is independently of the key that we're using. So time series are really a good way of getting this data. It all happens in real time. It's, let's say, around 1 second. So it's not real time, but almost there. So we like to call it real time. And because of the power of the configuration of Varnish, it's real flexible. So this was more a simple example, but now I'm going to give you a more of how to use this. Because, I mean, this is nice, it works fast, etc., but there is no real value in it. So we can do a lot of things with it. I'm covering some examples, but we could do like A/B testing. So we can measure the performance in real time of different contents and then decide what to publish. We can track conversion rates on online publications, so for instance, write articles more in a subject. You can see the audience is engaged in a subject, so you get your editorial team to write more content on that subject. And also, for instance, counting users per video stream. We have people using it for checking what's the most popular segment in a video, etc., things like that. So for A/B testing, for instance, we would use VCL like this. First, up there, let me see if I have that. Yeah. So here, we would just clean this custom HTTP header that we will create down here. And then for every single request that the URL matches foo, we randomly create this A or B. We set the header to either A or B. And then to the client, if there is this AB group set it, we create a cookie that lasts for 60 seconds with the name of the group. The next step is actually to check for that cookie. And if the cookie is not set, do the previous logic. But if the cookie is set, just make sure you set it in the header. And then here, we create a key that logs that header. So what this line is actually doing is inserting that key in the Varnish log. So the Varnish log I just showed, there's a stream of data that's constantly going, and then we just add a key with a header. And then when we query it, we are able to group it and actually figure out what's going on in real time. And here as well, I use the cookie to create a unique session ID, so I can even count how many different sessions I'm having. Another example is something that online publications use. So this graph, on the bottom, the x-axis, the now moment is to the right. So imagine that this is like the last 30 minutes. In blue, there's the front page clicks per second. So how many clicks we're having in a front page of a publication. In green, a specific article is measured, but here is the amount of hits that are coming from the front page to that article. So this allows you to measure the performance of actually an article, and then if the front page is doing a good job actually in moving people around the content. Another example, keeping also the referrer in mind in terms of where the traffic is coming from. This is for a given article. You can see that different sources of traffic are here displayed. And here we use multiple time series to create the different lines or different areas. And then we can see, for instance, that here the same 0 is there. And then after the front page, after a while the front page is linking the article, you can see that social networks start sharing it. So this is always through it's measuring the referral for a given article and the traffic sources. This is done by the simple HTTP header, that's the referrer header, that actually has the information of where the traffic came from. Of course, you can track anything HTTP. This is just a simple example. So a running example that's running on my machine right now. So I have a machine and I am sieging traffic on 2 Varnish Cache servers. And here you can see, for instance, as a UI that I've done on top of that JSON API. And it's a simple, here is checking the refer header. And I'm just simulating traffic that comes from different sources, Twitter, Instagram, and Facebook. And I can see, for instance, that which one is the slowest. By default, like I have all these metrics that were in that timestamp response. And I can see, for instance, that Instagram is the slowest. Of course, here the order of magnitude is not very relevant. This is just an example. And then out of the box, I get all of these details. I found 15 time series, and I can see how many cache hits, cache misses, and then the bandwidth it was consumed, the number of times it has happened here, sorry, the response time here, and the number of times it's this one. So hits, misses along the time. This is actually interesting because you can then also see server errors, top requested, for instance. Here you can see the top requested, and actually I'm just checking the refer key, but actually I could reset it and see everything. And then I've created this structure of folders, but this is basically the flattened structure, and I have 2 hosts, and then I can see all my keys here that I'm inserting, and I can see pretty much, yeah, so now the slowest, for instance, and I can see, okay, my slowest is this URL. But again, because everything is happening in my local machine, the magnitudes, the time difference are not that relevant. I can even see the size, and I can see what's the biggest object that is coming out from my web server, and if I'm maintaining like my web server, I need to tackle that. So this is just implementation on top of that JSON API. So this one actually is live right now. So this is not a video running on my laptop. This is actually coming from VG.no, Norwegian newspaper. And what this represents is the popularity of a given article clicks in their front page right now. So this is in real time. So the bigger the square, the more audience it has. And this has a 10-second bucket, and it's updating every 10 seconds. So what VG.no did was they integrated VCS with their CMS, and they fetched the corresponding image for the article that they see it's more popular at this time. So if I click here, actually, I can go and open directly the article. So it looks like this article is really popular right now. Yeah, so my takeaway on this is if you have some kind of issue, if you need to figure out what's wrong with your web application, Varnish Cache is a a good option to just check it. And while using it, you then get out of the box, you get the speed. And we have built this on top of the Varnish log, but you could also do it. I mean, it's just a usage that it's just some feature we created, but it's out there, it's open source, so I invite you to try. Yeah. So my goal here was to show the flexibility of logging and actually how logging in real time in a structured way, it's very, very powerful. So yeah, so if you have questions.